Hi everyone and welcome again to this course. My name is Miguel Ángel Manso. In the last lesson of this module, Representation and New Technologies, we learn about multicopter component and start to build one with Arduino. First of all, review the main multicopter components. The frame, for example, DGA frame wall 450, electric brushless motor and the propeller. Electronic speed controller, ESC. Usually lithium polymetal battery or LiPo. Flight controller, Arduino. Sensor, magnetometer, accelerometer, gyroscope, GPS or GNSS, and voltage and current meter to know battery choice. And finally, remote radio control receptor to control of movements of the quadcopter. Quadcopter controlled with ArduPilot. Sizing the multicopter depends on payload weight, for example digital camera and 3D gimbal, the weight of the frame, engines, propeller, electronics and battery, flight autonomy attained, and weather condition, wind, humidity, temperature, etc. To calculate the flight autonomy, the weight of the entire multicopter at takeoff, including payload, must be calculated. The characteristics of propeller and motor operating and consumption regime must be known to calculate the power consumed to support all the weight in stationary conditions. Once the combined consumption of all of the motors and electronics has been calculated, ESC, RC receiver, sensor, Arduino, depending on the capability of the battery, and the maximum flight time of the equipment can be calculated. Always keep in mind that the conditions won't be the ideal, that the multicopter has to rise, move and land, and this requires extra power consumed. Arduino function in multicopter. The Arduino basic functions are receive information from the inertial system, gyroscope and accelerometer, and establish the multirotor, pitch and roll, and control the speed of the propeller of each motor, receive orders from the radio control station, and execute the movement orders that it sends, throttle, yaw, and displacement. Arduino Uno 1 multicopter YMCL project example. In this figure of the slide, you can see first of all the electric connection diagram of the gyroscope, the electronic speed controller, the output of the radio control receiver, and some resistor and LED diode. In the second one, you can see how the gyroscope has been placed on the chassis plate, oriented it in such a way that the arrows printed on the backlight fit with the north of the multicopter. In the third one, you can see how the Arduino controller has been fastened on the chassis with spacers to lift free the gyroscope and the radio control receiver, and how the double ending guides have been placed to connect on the Arduino board and to be able to perform the welds. In the last one, the final result is how, after carrying out the welds according to the initial schema and placing the heat shrink insulators. Programming Arduino to copter the multicopter to control the quadcopter. Manage ESC from Arduino in order to control counter electronic speed controller. 5 sequential steps must be done. Read zero angular rate data, calculate proportional integral derivative corrections, calculate the pulse for every AST, compensate pulse for voltage drop, and send the calculated pulse to the ESCs. With a loop of 250 Hz, 4000 microseconds available, 300 microseconds read angular data, 600 microseconds to compute, and then max pulse length for ESC is 2000 microseconds. ArduPilot based on Arduino board ATmega controller. ArduPilot 2.6 is an Arduino board with ATmega microcontroller. Several sensors include gyroscope, accelerometer, and a barometer. It is possible to download the developer tools at http://download.arduPilot.org/wiki-download/developer tools. This Arduino board can be programmed with the Arduino Integrated Development Environment used in the previous modules. It is possible to download developer tools from ardupilot.org website for different platforms. Creating a new sketch with ArduPilot libraries. In this slide, we can see how to create a sketch program from including several libraries, defining constant and variables, and the loop and the setup functions. After load an init serial monitor, we can see reads from the three angles. Then we can move the ArduPilot to read new values updated. Using AP inertial sensor sample MPU6000. Then we can open ArduPilot Arduino 103 Windows library AP inertial sensor sample MPU6000 and load ArduPilot and init serial monitor. With the test option letter T, we can obtain lectures from accelerometer, acceleration and speed. Then we can calibrate MPU6000 using option C. For it, will indicate a set of instructions to follow. Place the controller at the level and press a key, and then left and press the key, etc. The order of the position is normal, left, right, down, up, and back. Using Baro EMS 5611. Then we can open ArduPilot Arduino 103 Windows libraries AP Baro MS 506011 test and load ArduPilot and init serial monitor. It will show us the temperature, pressure, and altitude readings. That's all. Thank you. See you soon.